Hi and welcome to DBJ 3D Printed Solutions chromatography frame. I thought I'd make another short video just to show you how to put the frame together and to do a quick paper chromatography run. Before you start, you're going to need a few things. You're going to need some water or some other solvent. You can look into solvents later. Pens or textures with a bit of colour in them, and some chromatography paper. If you don't have chromatography paper, you can use filter paper, and we'll just cut that into lengths, and I'll show you how to do that in a moment. Now, our kits come in bags like all of our kits do, and this one's a little different. It requires a little bit of assembly. That's pretty straightforward. We have a base, we have a couple of posts. Now each of the posts have got little notches in them. I like those notches on the bottom. So I'll put the posts in first, and the post should come close to the well here, and then the top simply goes on top. And there's our frame for our chromatography. The wells here is where we're going to put our liquid, our solvent. Now we need to make some paper. So I'm going to take a piece of filter paper. I'm just going to trim it to about 10 centimetres in length. So if I take a centimetre or so off this side, and a centimetre or so off this side, I end up with about a 10 centimetre length this way. I'm going to try and cut it perhaps we'll make it 4 papers, about 1.5 centimetres wide. There's 1, 2, 3, and 4. So you can discard all the other little pieces, and we have our 4 pieces of chromatography paper. Now, the goal of chromatography or paper chromatography is to get our sample to move through the paper. The paper is going to act as a solid substrate for the solvent, water or methylated spirits, to move through. And as the water moves through the paper by capillary action, it's going to pull with it any water-soluble inks and cause them to spread out. So I'm going to put a dot of each ink about 1.5 centimetres up on our paper. Now, the little notches in the frame are at 1.5 centimetres. So if you're not sure where 1.5 centimetres is, you can measure up against the frame, or you can just take a guess like I am here and putting a dot where I think it needs to go. Now, once we have our papers with their inks on them, they simply slide in from the top into our frame. Now, if you want to do more at any one time, you can cut your papers thinner. It's up to you. They just sit there. Now they must have their feet, if you like, in the well. So when we add our liquid to here, it will rise up and take the inks with them. Now I'm just going to use water for this example. I've got a small syringe here. I'm going to draw up about 6 mils of water. Each well here holds about 3 mils. Now there's 2 wells. The reason there's 2 wells is you might choose to do different liquids in each of the wells. In fact, I won't do that, but you can. Right, and you can see straight away the water is moving up by capillary action through the paper, and any water-soluble materials in those inks will move with the water. So if we give it a moment or two, let's see what happens. Well, that's been about 5 minutes now, and you can see there's been a bit of movement in the red. There's something water soluble moving up here, and there's something water soluble moving here in the red and the green. But the black, and maybe there's a faint yellow here. I'm not really sure. Certainly the blue doesn't appear to have moved at all. What I want to do now, I'm going to quickly change that one out. In fact, I've got one behind us here. Why don't we use this one? And I'm going to swap the solvent this time. Instead of using water, so as they always say, here's one I prepared earlier. Instead of using water, let's use methylated spirits and see if we get any difference. So I've got some methylated spirits in the syringe now. I'm just going to add that to our well. And let's let that run for 5 minutes. So that's been about 5 minutes now, and you can see there's quite a difference in the movement of the colours with using methylated spirits. The blue has certainly very different from what it was in the water. I'll show you the water alongside. I left that running, so that's been going for 10 minutes now, the water. And you can see there's quite a difference, especially with the blue. And the black, I think I'm definitely seeing some yellow now at the front of the colours on the black. You can experiment with larger dots or smaller dots. Smaller dots might be a little bit more precise. You could use lines, and certainly lots and lots of different inks. You need, of course, to work out what's if it's going to be water soluble or if it's going to be more soluble in methylated spirits. But there you go, that's how paper chromatography works. I hope you enjoyed the video, and remember to visit us at dbj3d.com.au to find out what's new. We're always developing new kits. So yeah, thanks for watching, and goodbye. Hi again. I thought I'd take a moment just to have a look at the results of that activity we were just doing. We've got methylated spirits here on the left, and the water here on the right. Now, bear in mind that the water certainly did run for longer than the methylated spirits, but what is obvious is that a lot of the dye in the colours that were in the water seem to have stayed relatively in their position. So it suggested they're not terribly water soluble, and also that they may have a strong affinity for the paper. They not just stick to the paper. This red obviously has got a trailing red band here, so there's some water soluble red. The green had some water soluble blue. The black's got some water soluble yellow here. You can just see a faint yellow. Blue, nothing appears to have moved. Okay, so no water soluble blue dyes there. Conversely, on the other side, with the methylated spirits, you can see this is where the original dot was, and nearly all of them, the dyes have moved from that position. So that suggests they're all certainly soluble in methylated spirits. Now, the red looks like it's predominantly going to be red. Maybe there's a little bit of an orange front there. The green's interesting. We've got some blue here in the green that's soluble in the methylated spirits, and I anticipate there's some yellow around here somewhere as well, because blue and yellow, of course, give us green. The black has moved, and again there's a bit of a trail here, which suggests there's probably some other colours amongst it. There's certainly yellow right at the front here, and maybe there's a bit of red tucked in there just behind the yellow. And the blue looks like the blue's done predominantly all blue. There doesn't appear to be any other colours there. So typically what happens is you get blues, pure blues. Blacks are generally a mixture of other colours, blue, red, and yellow quite often. Green, blue and yellow. Red typically also is usually just the one dye. So there's my example and the results from such. I would like to have run them longer. Time was of the essence a little bit, but if you get time, run them a bit longer, see if you get greater separation between the colours. But once again, thanks for watching, and I hope you enjoyed.